Itulah wajib son. Wiri. Eva nada.
Eko muri?
Nani registrerando? Page put down a group na price. Think kaisa number ko things
for Can I be heard?
Hello? Can I? Huh? I didn't get you.
Yes, you can.
Okay, perfect. Can you guys see the PDF?
Yeah.
Okay, perfect then. So, we're going to start. We'll do this very quickly. I'm sure last time I had said, first and foremost, all questions should be asked towards the end of the lesson so that we don't drag and don't take long to finish up because there's so much I have to cover. So if you have questions, try by all means to remember them so that you can at the end of the lesson. Is that okay?
Okay. Oh, okay.
Excuse me. The person with the microphone on, please turn your microphone off. The lesson has begun, so I would really appreciate if you guys were to respect the lesson, please. Thank you. I'm sure you guys did what.
I also have a suggestion in terms of the questions so that they don't forget. Maybe they can write in the comments, then at the end when you are done explaining, you can be reading them. Then you
All right. Anyway, so I'm starting. I'm sure you guys can see that today we'll be looking at complex numbers. Yeah. So your questions at the end of the lesson, please. So complex numbers, I'm sure you guys, does anyone have an idea what complex numbers are? Is there anyone with an idea of what complex numbers are? You guys don't know what complex numbers are?
Complex numbers are numbers which can be written in the form a plus ib.
You guys, I'm sure everyone here, I'm sure you guys can all remember the formula we used to use back at home when you are finding what are you finding? When you're finding, like, when you draw a polygon, then when you're trying to find the equation for the polygon, let's say trying to find the numbers for the y and the x axis, there's that long formula we used to use where I think it was, what was the formula? Is it negative b plus or minus square root of, what's that? Is it a squared or s squared, or b squared minus 4ac over 2a, I think, something like that. Yeah, so that's what we used to find. Like, that formula it comes back and it's used whenever you're trying to find Racing, trying to find, we're trying to solve complex number. You guys can here on the screen. Yeah, here on the screen, you have this formula here. There's negative b plus or minus square root of, you have that triangle there over 2a. This triangle here is here. This triangle here represents negative b squared minus 4ac, and everyone remembers this formula, and you guys all know how you apply it. Only when you look at quadratic equations, that's when you can apply this formula for you to find what is y and what is x, isn't it? So no, what is x, whatever. Yes, yeah. But this formula is used when when working with quadratic functions, yeah. And everyone remembers it, and I'm sure everyone knows how to go about it and when to use it and why it's used. So I'm not going to go back to explaining to you guys basic mathematics that all of you guys already did. Yeah. So that's just the fact here is talking about complex numbers. We use this formula here. It's used. So not this formula. Remember this formula. You guys are going to look at this deeper when you are doing in algebra. When you're looking at this solutions, those things, this is going to be used in algebra. Same thing goes with, where is this part? The same thing goes with all the things. Yeah, so all this, you're going to use this in algebra. Yeah, you won't really need it in Analyse unless otherwise. Yeah, but algebra, you're going to find all these things. Yeah, you're going to do more in algebra, these things. So you guys remember the formula? Remember the formula in what this triangle means? It means that everyone knows the formula. Perfect, we move on. Yeah. Then here, I was looking at multiplication and addition. This part here, how it can be, how you go about it. I'm sure you guys know all this. Why is it like this and all that? You know that when you're looking at such, you know how plus sign, the multiplication sign, these ones are, they're very accommodating to each other. So you guys know why this and this are like this. The same thing goes with this as well. Yeah. I'm sure you guys know, because all this is just basic mathematics. You guys did this. But if you can't remember, please, you tell me. No, I can't remember. Because if you guys are quiet, me, I'm going to assume that everyone knows, and I'm going to move on. Yeah, let's see. Okay, the same things that is here, just notes. You guys should remember this. Yeah, that I squared is equal to -1. All this right now, use all this in algebra. Yeah, but this is very important. Remember this. So note this and not the other formula. Make sure you note them. And these are just simple properties. You're going to need these things when you're solving questions in algebra. Yeah, so all these things.
Well, the messages that I think you should see, Mono.
Let me see the messages. Okay, let's see. So others can't remember, but it told us to be quiet. Teach like it's our first time. What is the time now? That's a bit by the punch back. Okay. Well, first and foremost, let's do this. Okay. From here, I'm going back to where I started.
Excuse me.
Yes.
Yeah, I was thinking it would have been better if you just explain to us everything, because we'll have more understanding than we did the previous lesson.
Yeah, so now.
All right. So I'm going to start afresh. First, I hope everyone is doing the same. On today's lesson, we're going to be looking at complex numbers. Under complex numbers, you're going to find something called polynomial. This equation here is an example of a polynomial. What's a polynomial? A polynomial is basically an equation which has the power 2 to it. That can be a polynomial. But at times polynomials go on and they can have the power 3, 4, 5, yes. But normally they start from 2, the power 2. An example of a polynomial is here. It's been given here in form of a quadratic function, which is ax squared plus bx plus c, where a is not equals to 0. Yeah. And whenever you're looking at such an equation, yes, such an equation here, you normally have 2 racines. Because you have, when you look at the formula, you've got 2 signs, plus, and you've got the negative sign here. I'm sure, I don't know whether you guys can remember how you go about using this formula here. Yeah. So when you look at this formula here, the first thing is we've got letters. You've got the B here and you've got the A here. And B and A represent something when you're looking at, when you have been given an equation. Like in this case here, let's say for example, the A here is 2 and the B here is 4. So when you get this equation here, whatever your B here and whatever your B and your A is in the equation is what you replace in this. Yeah, is what you replace in the formula here. And then when you look at this formula, there's also something which is here, which is a triangle. This triangle represents a formula too. So basically why the triangle is here is just to facilitate and to make the formula look much easier, and so it can be easily remembered. Because if you were to put this here, it's going to be a little bit harder for others to remember. So it's here so at least it can help one remember and not forget. So you guys should know, yeah, you should know this formula. It's very important, and you're going to use it when you are solving questions in algebra. Yeah. So this is going to be used in algebra, and it might be used like a few concepts that you might use it sometimes, yeah, in Analyse, but it's very rare. But this is mainly focused in algebra. Yeah. Whenever you're going to look at polynomials and all that. I don't know how far you guys are going in algebra, but definitely you see how this is more applicable in algebra. Yeah, so make sure you note this equation here. It's very, very important that you guys note this equation here. So this formula here, and you try and remember what you guys did back at home. I'm sure Ernest had said that later on today, you guys are going to solve questions like just basic mathematics, so you guys can remember. I'm sure he's going to bring questions like this. If he doesn't, let me know. But yeah, this is going to be there, so at least you can know, because this formula is going to be used a lot in algebra, and very rare is it used in Analyse. Yes, yeah, so that's for this part here. Yeah. Yes. So I'm sure you guys remember things like commutative, what's the commutative, distributive, and all those terms whenever you're looking at the mathematical signs, which is addition, multiplication, subtraction, and division. So this here is the first one here is basically like distribution, because you've got the A and you've got the B, and this here is, I think, yeah, you've the A and the B plus C and D. So what happens is this isn't distribution. Yeah, so what happens is this part here is rewritten in this form here. This part here is just showing you how the addition sign and the multiplication sign go hand in hand, or how they can be both incorporated. I'm sure you guys can actually tell or remember from what we did back in Zambia when you're looking at mathematics. Yes, these simple things. Yeah. Okay, sorry. I'm going to read your question. When it's a question, a suggestion, or whatever it is, it says we have a limited time in the summer lesson, so we need to cover the hard stuff. Okay, so first of all, I'm going to stop here so that you guys can tell me exactly what it is that you guys want me to do. Because when I began to explain these things, I was roughly explaining, because these things, everything here I'm explaining, you won't use it in Analyse, but you're going to use it in algebra. Yeah. So I perused through all this. I said master this, and I went on. Yeah. Then someone says, please read what's in the chats. I read your chats, and you guys say don't remember anything. Others, no, explain everything. Okay. I begin to explain everything step by step. Then I go and read the chats, and then we now say, we have a limited time for summer lessons, and you want to cover the hard things.
Oh,
So,
sorry, I didn't mean you. I was telling the guys, you're just fine. The pace is just okay.
No.
So we're sorry for that. It won't repeat. We've stopped.
No, hold on. Communication here. So, what do you guys want me to do exactly? Please, someone tell me.
Okay, excuse me.
Speak, I can hear you.
Okay, so we cannot go on learning without people understanding what is behind. So it's better you help those who are behind rather than going on leaving us behind. So if you think you are ahead of us,
yes,
anything,
please, you can wait for us.
We are visiting you.
Yeah, so for us, move fast. What is important is understanding the concept. What is it are we going to benefit if we move very fast and then not understand the concept? So what is very important here is understanding the concept. That's it. Moving very fast is not even.
You guys, you're disturbing the professor. Let her continue teaching.
She said we stop and hear. She said she's going to stop so that she hears what we think. So you guys, let's make up our minds. What do you want? What do we want?
We don't want her to be moving very fast. We want to understand things. So someone wants her to be moving very fast. I think that doesn't qualify, because we want to understand. If we understand the basics, then we'll be able to handle the questions. So I'm against of moving very fast.
Exactly, Samuel. You're right.
But you've done this in algebra.
Exactly.
Not everyone is taking algebra. That's what you have to put in your mind.
You can I think. And
in fact,
You guys, you're just wasting time talking to me. Let her just continue learning.
Okay, then keep quiet.
Oh, teaching. Yeah.
Inshallah.
Are you guys done?
Yes, we are done. Please, you may continue.
Okay, so from what I've heard, you're saying quite right. Definitely, I do know that there's no point of moving forward when people don't understand the basic concept, which is very understandable. And yeah, I hear you guys. Yeah, that's the first point. The second thing is that someone says these things in algebra, and then there's someone else that came to say, well, not everyone is taking algebra. So one, I had no clue that not everyone here is taking algebra. I believe isn't algebra in every, I don't know, anyway, whatever. Yes, I thought algebra is taken by everyone, just like Analyse is. Yeah, so for those who don't take algebra, I'll tell Ernest to give you examples on the formulas, how they use polynomials and all that. Even though when you look at these same polynomials and the first part I was from explaining, all these things you did them in math back in Zambia. And if you tell me you've forgotten how to solve those equations you used to solve in Zambia, where you've been given that graph where you had to draw that curve, whatever it is. Yes, yeah. So I need to tell me that no, you've forgotten, then I can now explain. Yes, yeah. So yes, there's not much time for the lesson and all that, but then you guys should come to realize that when I move fast on something, it's because I know that particular thing I've moved fast on and I haven't explained more on is because it's not really gonna be there. There are some things that even though I explain them right now, you guys still won't get them until we move to a topic where they're actually applicable. So this first topic here, majority of you guys, or maybe quarter of you guys, don't understand whatever it is I'm going to be explaining. But as we move on to the next topic, which is sweets, all these things are going to be applied, and this is how you're going to be able to understand all these things. Just like what we did last week, what did you do? Majora, all those things. I'm sure most of you guys didn't understand. Maybe some did understand. Yeah. So you understand them better as you move forward. Right now is for you guys to understand, at least know it, and but for you guys to know, okay, in Analyse there exists this and this, and there's this. So even as the terms come as we move forward, they aren't strange. They're actually there. You'll be like, okay, no, I remember this at the beginning, and then we're like, okay, so that time when Mono had brought up this, it was brought up because of this. And this is now how I'm able to now use it in this particular thing. So quite right, yes, yeah. We're going to take time, just like last week, for me to explain step by step. You guys asked so many questions and all that. I know because I've been in your place before. Turn off your mic. Turn off your mic. Turn your mic off. Thank you. Yes, I've been in your place and I know exactly how it is like to be in your shoes. And yeah, otherwise, I hope you guys have understood. I'm tired of talking like this. Yes, I'm going to go on from here, from this part here. I'm going to go on from this part here. If you have any questions, you tell me your questions, whatever it is you want to ask. Yeah, but right now I've run out of time, so I'm going to go on. There's a very short part on this first topic. We have to move on to the next topic. Most of the things which you guys here are going to see, most of these things are going to be used in algebra. And even though these things, for those who don't take algebra, even all these things, everything here you see, all these things you see, all these things you see, you barely use them in Analyse in the first place. But if you want to know them, fine, we'll learn them, period. Yeah. So I'm going to continue. Yes. Yeah. So where was I? Yeah, okay, from here. Yes, so for this part here, for this part here, it just, I'm from explaining this part here, it just shows you like how the addition sign and the division sign, how they are, these two actually, how they are brought together, like how they can be used this is, guys, this is A comma B, and this is C comma D, and it's been rewritten to A plus C, B plus D. I'm sure when you like solve the, like when you try to write these in form of matrices, you'll be able to understand that when you solve matrices, you're able to further understand why it's like this. Yes, yeah, how these, when you add these two, when you like write them, they can be like this, because it's A plus C, and then it's yeah, A plus B, A plus C, and then it's B plus D. And then when looking at the multiplication sign, it's a little bit different. So you have to note these properties. You note this property, you put a star on this property and on this property too, because these things, as you go further, you're going to actually use them. Yeah. And then this sign I is used. Yeah, I is used in complex numbers. In complex numbers. So whenever I see this I, you should know that this I is because this I represents a complex number. So don't be surprised when you see an I. Not okay, there isn't an I. Whatever figure I've been given is a complex number. Yeah. And then yeah, complex number. Then for example here they gave us 0.1. Yeah, then I squared you've been given, we know that 1I is equals to 0.1, right? Then I squared, meaning that this 0.1 is going to be multiplied twice. And when you solve some matrices or whatever it is, you find something like this, I think, probably. Yes, yeah. And then I squared is equal to -1. This right here is a rule. This here is a rule. And you have to remember this. This you should not. You have to remember this. Yeah. Because there are times when they might give you an equation, then they'll put I squared. Remember, oh, okay, then put I squared. Then you can be told to find something. So you don't forget that I squared is equal to -1. This here you should remember. Yeah. Remember this. Yeah. Yeah. Then just, just like here, and we all know that this part here, yeah, to get rid of the square roots, the square, you have to square root both sides. So it becomes I is equals to square root of -1, which is what has been written here. Yeah. Yeah. This here is an example of, this here. You've been given an example here. You can see this I here is present here. You already know, oh, okay. Why is it there? This is a complex number. You can see the I there. Yeah. Normally at times they can give you an equation. Maybe it can be 2 plus 3i, no, 2 plus i3 or whatever. But as long as there's an I there, no. The first thing you remember, okay, first of all, it's a complex number, and I squared is equals to -1, and then you know that I is equals to square root of -1. So already you already have a foundation on this part here. Yeah. All these things not here, irrelevant. Yeah. Let's see. Yeah. You note this, all these things, all these things, you note them. These things, this is just basic theory, just reading. Yeah, these things, this is just a formula. You have to remember this formula. I'm sure it's used. Yeah, it's used a lot in algebra. These things, you're going to use all these simple rules. There are a lot of them found in algebra. They're normally used in algebra. Rarely are they used in analyze. Yeah, but you get questions from Ernest where I'm sure he will solve all these things for those who are not doing algebra to accommodate everybody. Yeah, these things here, you have to note all of them. Just like I said, you should note the other things as well. You have to note all these things, the meaning of what it means and what it means, so that you don't forget. You remember all these things. Yeah, there's the same things here as well. All these things have to be noted. Yeah, because all these things, I'm sure for those, I don't know how far you guys have gone in algebra, but I'm sure you've begun to look at these things, and he's begun to explain, and I'm sure solving some questions too on how they're used, why they're used this way, and all that. Yeah, all these things, all these things here, simple properties, you have to remember them. You swatter them, you remember them, and you know how to use them. Yeah, by questions. I'm sure that you've been given questions. Yeah, complex numbers, the sign for complex numbers is a C, like this. Yeah, and you guys should make sure you remember all the signs that Ernest had taught you the first lesson. Yeah, make sure you remember all the signs, so at least it can make things much easier for you guys to understand. But otherwise, all these things, you're gonna find a lot. You're gonna find a lot in algebra. These first things, exponentials, things, you're gonna find these things, and these, as we go further, we're going to be able as you go further, you got to understand how to use this and all this. Yeah. Yeah. So all these things are going to use them, not now, but later on. This, not now, but later on. Yeah, so before someone comes to ask me a question, I'm just this here, you just see it and you just say, oh, okay, there exists such a thing. So as we go further, you'll be able to see, yeah, this Z here represents an integer. So it can be 1, 2, whatever it is here. Yeah. And then this small Z here, yeah, this small Z here, the same thing. So this, where there's Z, you can put a number there. N represents a power. To the power n. To the power n means that you don't know where the power ends. Yeah. Yes. So this is for this part here. We're going to do further look at this as we move on with the topics. Yeah. Yeah. This has to be remembered because you're going to use this a lot in algebra as well. This is in algebra, and it might, yeah, it comes as well in Analyse, but we'll see, yeah, as we move forward, how we're going to apply this into our solvings in our questions. So, yeah. So just make sure that these things, at least you know that they exist, so that as we move forward, both in algebra and Analyse, you guys can see that, okay, I remember this, and this is now how it's used. The first chapter is basically just to open up everyone's mind, so that you know that, okay, there exist these things and all that. And as you move forward with the other topics, you get to know how to solve them and what happens, why is this like this, what does this mean, why is it like this, how am I going to apply this to a question and all that. So right now it's just they're brought here so that as you actually look at them, they don't look strange. Yeah. So that's that. The same thing with in here. Yeah, this equation here is all the same thing here as well. Yeah, we all know whenever you're looking at powers, you know that when you have something to the power and the power there and the powers there, you know that, so they're added. You know that when you distribute your whole number, it now becomes multiplication. I'm sure we all remember this back home from the base that we did. Yeah? So that's that. Otherwise, all these things here are put so that they don't seem strange as we move forward with the other topics. So at least you can remember them, say, okay, I remember seeing that the first time, and okay, now it's applied like this. Yeah, let me just look at your questions, in your chats. Oh yes, yeah, sure, yeah, you can ask questions. Go ahead, ask your question if you have a question. Before I move on to the next topic, you can ask your questions. Yeah. There are no questions, I can move on. No one has a question.
Kindly explain on the De Moivre's theorem.
Which theorem?
De Moivre's theorem.
And there is one question in the chat.
Sorry, what's your name? The guy who's told me there's a question in the chat.
Pardon?
What's your name?
Samuel.
Okay, Samuel, you do this. You're gonna help me. So you'll be, if the question is in the chat, you should be telling me there's a question in the chat. So Samuel, you should be doing that every lesson. Samuel, you'll be doing that. You've heard Samuel.
Okay, sure, no problem.
Right?
I didn't get what you said. They are making some noise in the background.
Oh, I was saying the guy who had the question. Okay. Is it this part here? This is the question you had? Huh?
Yeah. Just there.
Here, you have to explain. This cannot be explained. This means this. I don't know that. Do you take algebra?
Yeah, I do.
So if you take algebra, I don't know whether the guy who takes in algebra has already explained this, but e to the power I, e to the power I and that in this sign here, this is what it means. This is just the meaning. This cannot be explained. It's just the meaning. Yeah. This the exact same way let's say what's the exact same way we can say that other formula I was saying you about, where it's the one for the polynomials. Same thing. Just like I said, I to the power 2 is equals to -1. The same thing here as well. So let's say, for example, you've been given a question and then they put, then you've been given this sign. You've been given this, right? Yeah. So when you've been given this, then maybe you've been told to simplify. First thing that should come to your mind is, what does this mean? This means cos pi plus I sine pi. That there, you know. Yeah. So this here is basically just the meaning. The exact same way we have e to the power z. E to the power z is equals to 1 plus z over, just like that, yeah. The same thing here as well, yeah. So this here is basically just the meaning, the exact same thing as here, yeah. How this can be further simplified is like this. How is this simplified is like this. How is e to the power z simplified is this. This is only to a condition, this has a condition to it, and we'll look at this further as we move on, yeah. So this is just the meaning to help you simplify if you've been given a question, yeah. So that, because we know that you can't punch this in the calc, but at least, you know, on the calc you can actually use cos pi and the sine pi there. And how do you, and we all know that we all know what the I stands for, yeah. You know that I squared is equal to -1. So what can you replace with the I so that you can make this equation here easier? There's that formula I gave you guys, it's on top. So this here is just a meaning, yeah, to help you as you solve questions, as you simplify things. That's just that, yeah. There's nothing complex to it or anything like that. I'm sure you guys, as you go further in algebra, you're going to actually think should be in the first topic. In the first topic, you guys, I think you guys should have already have done this. Yeah, otherwise this should have been done by now, if I'm not mistaken. Yeah. Because in Analyse, it's not really, there's no much of complex numbers in Analyse. Yeah, so yeah, but the cos and the sines and the e's, the exponentials are there. But the way it's been written here, it's very rare to find it like that in Analyse. Yeah, so you look at that further when you look at algebra. All these here questions, yeah. I'm sure you guys have already answered questions. You've already done your TDs with NS, so I'm not going to look at any questions. Yeah, like all these things, you find all these things in what is this? This, yeah. You find all these things in algebra. Yeah, how you simplify these, yeah, simplify this. How can you go further? I'm sure you guys have already done this. Have you guys already solved such questions in algebra?
No, we haven't.
No, not yet.
I have a question.
Yeah, sure, go ahead.
Haven't we done this in algebra?
Sorry,
No.
back a bit. You can scroll up where it was written, open bracket, a comma b multiplied by c comma d is equal to
This one?
yes. Where was that negative coming from?
This negative here.
Yes.
This part here is basically just like this here. This is basically just a property. These are all just properties. So when you see something like this, you see how here it's plus and how here it's times. This shows you that whenever you're looking at, because this here is like these are like matrices, these are like groups, like A and B, then go C and D. This is one group, this is one group here. So the way that this here has been written, this is the first property of how something can be written like this. The same thing with here as well. So you have to note these two, yeah. these two, you have to note them. Yeah, this is why it's minus BD, and then here is plus BC. So basically here, these are just all properties, and yeah, these are all properties. It's like the meaning. It's like, how can this be written in another way? It's like this. How is this written in another way like this? It can't be explained why there's a minus here. It's basically just, it's like a rule. Yeah, I should say. Yeah. Are there any other questions before we move on to sweets? There are no questions. I can move on. Huh? All right. So, huh?
Can move on.
Okay. All right. All these things, you're going to look at them in you look at them in algebra. Yeah, all these things. You guys have done this in algebra, right? Have you?
Yes.
No.
Yes, yes. Yes, yes. Yes, we have.
That no. Okay. So yeah, I've done all these things in algebra. Perfect. So you can move on. Yeah. So today we're going to start. We're going to move to a new topic. And this topic is very important. All the things that we did last week, you slowly begin to incorporate them in this topic, which is sweets. Yeah, which is sweets. So all those things you're told to note were in the first topic, make sure you try and go through them, because this topic is very involving. You're going to have limits. You have to explain why is it majorant, why is it mineral, and we are born inferior, born superior. So as you move on to this topic, it's very, very important that you guys remember all the things you guys did in the first chapter. Yeah. So the first thing under sweets, the first thing we're going to look at is limits. Yeah, limits of a real sweet. Yeah. So basically, a real sweet is a family of values found in R. And what is R? R represents real numbers. Yeah. And a sweet is noted as U and a small n. This is the sign here for a sweet, where n is a member of natural numbers. Yeah. So whenever you're looking at a sweet, whenever you see a big U and a small n, just know that that's a sweet. Yeah. Know that, okay, now we're talking about a sweet. Mm-hmm. Yeah. Yes. So then you have, there's a condition. So as well, whenever you're looking at a sweet, you have to look at what the n represents here. There are times when they can say n is a member of Z, Z plus, Z with a star, Z star plus, all those things. Yeah. So Enes said that he had taught you guys signs at the beginning of the first lesson. He told me he had taught you guys signs. So make sure all those signs he taught you guys, you remember them. Yeah, such unconfused, and you don't mistake things as you guys are solving here. Yeah. Because if you don't understand this part here, you're going to make a mistake as you solve them. And it's very important that you understand each point here. And this point here is very, very vital whenever you're calculating sweets. Yeah. Because this part here can change. So pay attention. Yeah. So when you're looking at sweets are different. Sweets are different from, sweets is first of all where you can now say, okay, now we've begun to now solve analysis. We're now doing analysis, serious analysis, yeah. In the sense that when you're looking at sweets is very involving. They can bring equations, they can bring limits. I'm sure you guys remember limits, right? Can you guys remember limits? Huh? Somehow. Okay.
No.
Can't remember limits. Okay. Anyway, Enya said that he's going to solve some questions for math with you guys. The math like we did when we were back home, so that you guys can like try and remember like these things and all that stuff. I know it's been a while since you actually solved such questions, so he said that he's gonna do that. Yeah. But if he does, if you guys won't solve limits, you will let me know. But I'm sure you're going to solve limits. Yeah. So we've been given examples here. We have this suite here, which is equals to sine n. Yeah. And we know that this, sine n. Oh, by the way, this n, where there's n, they can put a number. It can be U0, U1, U2, U3. So why here there's an n is because the suite here, because the suite here has an n here, and then they have a number. If it was 0, if it was 0 here, it would have been equal to sine 0. Yeah, so that's that. But otherwise, a suite, this is how it's noted. It's U and this small n. Yeah. So this is an example of a suite. Another example here, 1 over n. Yeah, another example here is e to the power n. Yeah. Oh, yeah. Then this is the first example. So whenever I'm looking at suites differ. Yeah, suites differ according to how they're going to be solved. I'm sure you guys, like when you're looking at logistics in algebra, I'm sure you guys were taught like how to solve questions, like how to prove questions. Yeah. Hey, how to prove questions. Let's say, for example, they tell you that they say 1 plus 1 is equals to 2, and then prove that 1 plus 1 is equals to 2. Now, how will you do that? Yeah. So you have to make sure you remember those things, and you know how to go about them by using all the exam. I think there should be 5 ways in which you can prove an equation or prove whatever it is you've been given. So make sure you remember those things, because a few of those elements are used when you're solving suites sometimes, depending on what you've been given. Yeah. So all those logistics things, make sure you remember those things, how to prove. Yeah, how to prove. Make sure you remember those things. Yeah. Yeah. So we have another way of buying a suite. As I said, suites differ. This is the first type of a suite. So, as I said, normally a suite is the sign is U and the small n. But then now here you've been given U0, U1, yeah, or that can be U1, U2, U3, U4, U5, whatever it is, whatever it is. So all these things, you should know that they exist, and that's why it's like this. Yeah. So you've been given this here is an example. It says U n plus 1 is equals to UN plus UN minus 1. This here is like, this here is it's like a rule, sort of like a property, and sort of like a property as well, that at times it can be used. Maybe, for example, if you're given a question and you're told to solve the suite, and then maybe you've been given we told you to solve a suite. At times you are supposed to use this equation here to try and solve the suite, because each U there has a representation. So all these things, you know them, and you know the type of suite that it is. But otherwise, all these types of suites, like knowing the name is not necessary at times. Unless it's not necessary. No, it's not necessary. Unless otherwise. But just for your own good, maybe at times it depends with the kind of professor you guys are going to find, wherever it is you guys are going to go. Maybe they can be so harsh on you, and you guys know the names. I don't know. But to be safe, just try and know the names and know like what it means and what makes this suite like this and why is this formula like this. Otherwise, for the first one here, this is the representation. It's the representation here. This here is not important. Yes. The same thing here as well. No, the U cannot be a value. U cannot be a value. U is a sign. U is a sign. The only thing that can be a value is the N. the u cannot be a value. Yeah, maybe at times you can be given, it can be an example can be, let's see, let me check if there's an example down here of a suite. Switch to the number. No, okay, there's no suite here with a number that has been given, but at times you can be given like un. Yeah, un can be equals to, maybe you can say 3 un plus 4 un. Yeah, so the u cannot be a value, only the n can be a value, but u can be represented by a value, but it itself cannot be, a value. Yeah. Otherwise, I hope you guys are following. If you guys have questions where we've reached, please ask your questions.
Okay, I have a question.
Yeah.
Can you please show the screen? Yeah, this one. So when it comes to the u there, are we supposed not necessarily the u, but the n? For example, if the n is equals to 1, how are we supposed to add the two numbers there if we substitute with 1? And how do we play around the u there?
Are you talking about which one? This part here? Please repeat what you said. I couldn't get you properly.
Yeah, on that one. Mostly people. If we, for example, there's since you said n can be any number, and that number, for example, it is 1 for that. Then if we try to substitute there, we substitute in fact, and then I'm trying to, like, I want to know how we do the addition there, since there is the addition sign there, and how do we do, or how do we handle the use and the values that you substituted for the n?
Okay, I see. So how you do that is, for example, let's say you've been given un, and then here it's un minus 1, isn't it? So the first thing you have to note is that each un here has been represented by an equation. It can be 3 un plus, yeah, okay, let's say it's 3 plus 4. Let's say this un here is equal to 3 plus 4. And in the question you've been given, it says, okay, let's say here, yeah, it says un is equal to 3 plus 4, un plus 1 is equals to 7 plus 8, un minus 1 is equals to 10 minus 4. So in your question, they give you whatever it is, what this means, what it means. So that when you use this formula here, all you're doing is just going to substitute. That's all you're going to do. So you're always given in your equation what these things mean. Yeah, but it's not as simple as they can't give you like 10 minus 8. No, as we go further, we're going to look at some questions, yeah, on this part here, so that we can know what we're given and how we can use this formula. Otherwise, the un minus 1 and un plus 1, all these things, they give you an equation that is in your question. Yeah, otherwise this here is like a formula, I should say. Yeah. Do you know whether I've answered your question?
Yeah, you've answered. Otherwise, I was just getting confused on that part. Thank you very much.
No, you're welcome. Yeah. I saw another question. Can we define a suite? A suite cannot really be defined like by words. It's normally defined by an equation, like by solving. So yeah, I should say, unless you Google, but for me, I don't have like a meaning for what is a suite. Yeah, and all that. Yeah. But a suite can be defined by equations, by solving. Like, how in math, okay, even in physics, how something can be defined by an equation or by solving it. Yeah, that's the same thing with suites. Yeah, I hope I've answered your question too. Yeah, so are there any other questions before we go further?
So like which equation exactly defines the same suite?
Defines the same suites. Like this one here. Let me see. Let me go down. Okay, the first one that can define a suite is this one here. This here can define a suite. This here can define a suite. This can define a suite, or you can always, that can define a suite. What else can define a suite? This can define a suite too. It's the same thing, isn't it? Yeah, that can define a suite. This too can define a suite. Yeah, because you're looking at how, I think I told you guys how suites differ according to whatever it is you've been given. Yeah. So that's how you can define suites, basically, like by formulas and how they're solved. Otherwise, there's no like actual meaning for what is a suite, unless I have then just checked. Yeah, maybe if I check, I'll provide you guys with the actual meaning for what a suite is. Otherwise, a suite is basically just a representation of an equation where u and n is used to solve questions, I guess. I don't know. But yes, yeah, that's basically a suite. A suite cannot really be defined like word for word, but by an equation and how it's solved and how you go about it. Yeah. Yes, so I'm going to go on. So you have this, we've been given this other equation here, right? Well, I know that at times when you've been given equations like this, it becomes very confusing on how to solve them. Yeah, and though this equation here is similar to the one we've been given here, the only thing here is that we've been given an A and there's a B here, and this A and B can be any number according to your question. Yeah, so your question is going to determine what the A and the B is in this. Oops. Yeah, according to what your question has been given. Sorry, yeah, your question is, yeah. Otherwise, your A and your B can be any number here. Yeah, so that's that for this part here. Yeah, and remember that this N can be any number. Yeah, so always make sure that before you answer questions, make sure you read your questions properly, because it's in your questions that they give you information so that you know what is going on and how to use these and why am I using this? How come this here is like this? Yeah, so that's that for this part here. Yeah. Yeah, you also have to note this. Yeah, this part here, it says un plus 1 is equals to un plus a, where where a is a member of real numbers and this here is fixed. You have to note this part here, because as we are going to be solving suites, this is going to be used. So make sure you note all these things, you highlight all these things. Yeah, it should be highlighted. Yeah. You guys are going to see how it's going to be applied as we solve our questions. Yeah. Yeah, the same thing with this part here as well. The same thing, all these things, you note them, you note this, you note this. We're going to see how they're going to be solved in the questions. Yeah. Yeah, the same thing with this here, this one here. Actually, for this one here, as I said here, it's more general. Yeah, it's more general. And this fun, this is this fun is basically a function, and a function is equals to an equation. Like here, you've been given here an equation. It says, so basically this here, this here is equals to 2x plus 2 over 2x. So x squared plus 2 over 2x. So like, so like for this one, so like for this one here, it's like they're saying un plus 1 is equals to f of un, right? Now what is f of un? Here they've told you that f here is a function. For example, this same function, let's say it's f of x. Yeah, this same function in form of x is equals to this, so that, yeah, is equals to this, right? But then let's say, for example, it's a function in form of un. So meaning that where there's the x here, you're going to put the un. You're going to put the un in this. You put the un here. So let's say, for example, this equation here, right? So this this equation here. We'll put where there's x. We're going to put the un here. So it's going to be un squared plus 2 plus un. Yeah. So basically, this here is very, very general, like in form of a function like this. It's very, very general in form of a function. And as you guys solve suites, each point has a step. Each point has a step. And the first step is this part here. This is the first step here. This general representation here is the first step here. And this is applied, and this here is also going to be applied as you move forward, because solving suites has a step, and each point is very, very important as you solve suites. It's very, very important, so you're able to understand why is it like this and how do we solve this, because it's from this same function here we've been given that you're going to be able to know if you're able to know if it's bone superior, bone inferior, if it's majora or if it's minora. Yeah, so make sure you know the points and everything else with examples. Yeah, with examples we're going to be, you'll be able to know what point goes for this point and how this is actually going to be more applicable to this particular thing and everything else. Yeah, but right now I want you guys to know that, yeah, to know all these representations here. You know what this is, like you know that okay, there exists something like un plus 1 is equals to un plus a. Yes, and then it becomes different when it's geometric. It becomes multiplication. Yeah, it becomes multiplication. It now becomes un plus 1 is equals to a un. The same thing here. And then here when it's arithmetic, it's plus a. When it's geometric, it's going to be just a un. You know these things because questions differ. They can tell you to solve a suite that's geometric, and then how do you know it's geometric? Your question says so. And when it's geometric, what happens? You know, okay, because last time in the notes it said that un plus 1 is going to be equals to a un. So you know that okay, it's and here is different from when it's arithmetic, meaning the a here is multiplied, but then for arithmetic the a there is added. So make sure you always read your questions as you are solving, as you're going step by step. Make sure you read all your questions. Yeah, otherwise that's that. So you know, not that when it's an arithmetic suite, it's added. When it's geometric, you multiply. You not these formulas here. You not the formula here. You not this here. You also not this example here. Yeah, this example here, because sorry, this sort of formula. Okay, I'll just say an example. Yeah, this property. This property here, because it's very essential. Yeah, you know that. Yeah. So that's that for this part here. Yeah. Okay, let's see. No, this part here is okay. I won't do that. It's unnecessary. Yeah. All these things have to note them. You note all these things because these things here are actually going to be used. We're going to use them as we solve the questions and we'll further understand why we choose what and why we're choosing this particular thing as we solve the questions. Just note these things and you can write them down. I don't know whether you guys are writing down things or just highlighting, I don't know. But make sure this here is highlighted. It should be highlighted, yeah. And it's going to be further understood as we are going to solve questions under suites. Otherwise, make sure you note this as well. Oh yes, yeah. They are more like properties. They are more like properties. Sorry. What did I do? Sorry. Shit. Sorry, hold on. Give me a second. Otherwise, I hope you guys are following, and you tell me if you're understanding the things too, so that we're not just moving. Yeah, so that I know at what pace, if I have to slow down or I have to accelerate my teaching. So please let me know. Yeah. So just like the first point, yeah, just like this first part here, you note this part here, you note all these things, especially you note all these things, because like when you're going to be solving suites, yeah, as you guys solve suites, that you also have to explain why this and this. Like when you're looking at this kind of mathematics, you have to explain like why is this thing like this and this like that. So you really have to explain. So make sure that you note everything here should be noted. Everything here, all these things here, not everything. This here, note it, and we'll look at it as we're going to be solving the questions. Yeah. You note them. Yeah. Yeah. All these things should be noted here. Everything in this paragraph here is explained, is going to be explained well as we'll be solving the questions. Otherwise, don't worry about it. Yeah. Well, there's a question. What's your question? The person with the question. I don't know whether that's a question or not. Was that the question? Wasn't the question? Okay. All right. Yeah, and then here we've been given examples. Yeah, examples. The first one there says un is equals to sine n and is majorem. These here guys are just examples here. All these here are just examples here. Yeah. Everything here just examples here. Yeah. And like some examples that at times are given, you may not be able to understand them because there's no base of an explanation that's there, or there's no base of how it was solved and why was it solved this particular way. Yeah. But then when you're able to at least just grasp on the, yeah, when you're able to just grasp on the notes you've been given and you know how to apply them, it becomes much when you're able to now apply everything your notes say, it's going to be much easier for you to understand the things and know why is this like this and why is this thing like this here. Otherwise, these here are just examples. These here, all these things 1 2 3 4 5 are just examples. Yeah. Yeah, so that's that on that part there. Yes, let me see how far it is. Limits, bodies of a limit. Bodies of a limit. Okay. Yeah. Okay. All right. Anyway, on the part for like under suites, where I'm going to look at Majora and Minora for suites, I'm going to send you guys I'll send you guys some notes. I'll write down some notes. Yeah. Someone please remind me. Please do remind me. Yeah. Tomorrow. Remind me tomorrow. Yeah. So I should send you guys some notes on these parts. Yeah, on the bone, the bone superior, the bone inferior, major, minor, and how you're going to be able to apply them under suites. So that's something that can just facilitate you guys, so that in case you're confused, to just help you guys understand better. And yeah, so please someone to remind me. Yeah.
At what time?
Whatever time, but then before the end of tomorrow, just remind me. Yeah. Before you guys have another TD session with NS. So at least I don't know how far you guys have gone under the TDs. I've got no idea. Yeah. So at least when you guys are solving the TD for sweets, you're not confused and surprised on how things are being solved. Yeah. Otherwise, on that part there, I'll send you guys something to just help you guys understand better and easier. Yes. Yeah. Yeah. So, and then I'm going to then on this same property. So we'll do this on the next lesson. I'm going to explain on majora, minora, bone superior, bone inferior, under sweets. So I'll send you guys notes which are simplified, so that when I come and explain how you know when a sweet is majora or minora and all that, you guys are not lost. Yeah. But make sure you guys read the notes I'm going to send you guys. You should read the notes. Yeah. Let me just look at what's in the chats.
I think you should just start from the first, like writing the notes.
But then you've got notes here. Yeah. You don't understand these notes. Huh?
Like they are not clear.
They're not clear. So okay, all right. Okay, I'll write some notes and the person who's writing that, please stop it. The person writing all these things, please don't write. Stop what you're doing. Yeah. Anyway, I'll write notes and all. Yeah. I'll write notes on that part. Sorry, what did you say? The person whose mic is on? Please, the person writing on the screen, stop writing on the screen. You are distracting the lesson. Stop being a distraction. Yeah, otherwise, let's see. Otherwise, make sure you guys go back and actually like read through the notes and how far we've gone and everything else. Yeah, everything we did today and the things we did last week. You make sure you go through them and you try and make your own notes and see where you don't understand and yeah, all that. So that you know, the best thing actually is that as we are actually progressing, you as an individual, you also try by all means to read the notes before the lesson, so that you aren't so lost as we begin to look at these things. Yeah. As someone has said, there's not much time we have for these lessons, so it would be very helpful if you actually go through the notes. Yeah, if you go through the notes, yeah, so at least as we come, you are actually understanding. Yeah, you actually are understanding. Yeah. Because it's easier that way, because trust me, when you actually go to your schools, your professors are not going to have any mercy. They move, and trust me, they move in class, they move. Yeah, so it's a matter of you as an individual putting in the extra effort. So you have to make sure you put in the extra effort and you're actually doing the work. You do the extra work, you try and understand and all that, because everything here that's being done is for you, because it didn't make sense to have the lessons, then at the end of the day you don't put in the extra effort, you don't try and even get the books and say, okay, what did we look at last time and why was this like this last time and all that. Yeah, so do make sure that you put in the extra effort as an individual, because all these guys is for you and for nobody else here. Yeah, so make sure you guys do the extra work and you actually go through don't understand something, you ask questions. Feel free to ask questions. And if you want, you can also go on YouTube. You search. YouTube has everything. You search. You go there, you type sweets. You find sweets. The soft sweets, they're going to explain and all that. Yeah.
Morning.
Yeah.
Yeah.
I can't get you.
Yeah, the same one. What does it mean?
The E? That's epsilon.
Not the E, the A, which is upside down.
The A, or the A that's upside down for O. You got, wait, Enes told me that you guys did all these. All this, you guys did all this.
No. Some of us never attended the first lesson.
Oh,
we were doing French here by that time. We were doing French. That's when they taught it.
Oh, that's when the signs were taught?
Yes.
Okay, I see. All right. Yeah, okay. Anyway, let's see. I don't know whether your friends wrote notes on, I don't know, maybe you guys wrote something on those signs. Please, if you did write something on those signs, please help your friend and give him, please. Show him, okay? Show him what these signs mean. Yeah. Yeah. Show him show him what you guys did on the signs and all that. Yeah. So that he's not lost. Yeah. Otherwise, the signs are gonna be used a lot. You find them, a lot of them in here. Find them a lot actually, as we are going to be solving the questions. Yeah. Let me just analyze. Oh, yeah, welcome. Yeah. Yeah, so that's that. Yep, that's that. So let's see. So next week, the next lesson, is someone talking?
Yeah, I have a question.
Yeah, sure. What's the question?
Can you share the screen where there are properties?
The properties?
Yes, the properties.
These ones? These ones?
The ones that you talked about.
I've talked about so many properties, so which ones exactly?
Okay, I think these ones.
These, okay.
Yeah, so does this mean that sometimes the sweets, they can be like in form of those properties sometimes?
I can't get you, you're saying?
Okay, I'm asking like since we're having those properties for the sweets, so is it sometimes some questions they might try to present them in form of like their properties?
No, you use the properties to solve the sweets.
Okay, so like those properties are more like specific in terms of usage, right?
Yeah.
Okay, thank you.
Okay, you're welcome.
I also have a question.
Yeah.
Like the sweets, are they only used to solve the equations, or they have their own kind of representation? Like, do they represent something?
What do you mean representing what exactly? Be more precise with your question.
Yeah, like when, as in sweets, as in since they don't have a definition. Since we're not sure of the definition of sweets, but like, do they represent something? The sweets themselves, like when you're solving for sweets, what exactly are you solving for?
When you're solving for sweets, what are you solving for? You're solving for, okay, let's see. How will I explain this? Okay, so sweets basically, it's basically a way of solving equations. Yeah, basically a way of solving equations. And those equations you solve, you come up with different characteristics. For example, you come up with things like it being monotone, it being periodic, it being croissant, it being so many different things. So as you solve a suite, you come up with so many different things from there. So a suite is very, very diverse in the sense that this is why I'm saying all these properties here, all these properties here are very, very important, because when you're solving a suite, things differ. Yeah, things differ. You come up with so many different things, and small little things mean something under a suite. So basically, it's just you trying to solve an equation and trying to find out why it's like this, and different characteristics from the suite itself. That's basically the reason why we're solving suites. And suites do have a particular way of them being solved and them being actually done. Yeah, so they're very specific. They're different from how you solve other normal equations and all that. Maybe there can be a few applications, like how you solve like a simple, how to add like equations and all that, and different, or these small things. But otherwise in general, a suite is basically you're trying to solve different equations and trying to find different characteristics. Yeah, because let's say, for example, what you find at the end is equals to 4x plus 3. What does that 4x plus 3 mean? Yeah, that's basically what suite is about. Whatever it is you find has a meaning. What does this mean? How are we going to represent this? That's basically a suite. So for example, let's say you find, an example I gave you guys, where you say when we find 4x plus 3, that 4x plus 3 has got a step. Let's say that 4x plus 3 is your...
Guys, please turn off your mic.
Okay. Yeah, so what was I saying? Oh yeah, let's say, for example, the first thing you're given, the first suite you're given is 3un plus 4. They said, yeah, that's the suite you've been given, and then you've been told to solve that suite. Yeah, to solve that suite. Maybe they say un is equals to 3un plus 4, and then let's say then they say n is equals to 4. Solve that suite. Then at the end, what you find is 4x plus 3. Now, how have we moved from that 3un plus, maybe let's say plus 4, to the 4x plus the 4x plus 3? And why have we found the 4x plus 3? And what has changed during what has changed as we are solving each point? And so it's very important for you to know these simple properties, because all these are actually gonna be used, like majoram, minoram. All these things are very, very important, and the application too is very important. Because let's say, for example, you find you find the correct answer, but as you are solving, because in suites you explain, you have to explain. You write, you have to explain. You say, no, this is strictly that because of this and that. You have to explain. Switch, you explain and you solve. That's how it is. So let's say, for example, your answer is correct. The answer is 4x plus 3. But then somewhere you wrote that no, it's monotone, but actually it's not monotone. Or maybe you wrote that no, it's majora, but it's not majora. The whole thing becomes wrong. That's how strict suites are. So it's very important for you to know each point, you know what this means and how it is. Yeah, that's why you should know all these properties. You have to know them, and you really understand them, and you know how to apply them. Yeah, otherwise that's that. And next week, the next lesson, I think on Friday, we're going to start on limits. Yeah, on limits. And before I do limits, I'm going to first explain on the majoram, minoram, all those things. I'll send the notes I'll send tomorrow. Make sure you go through them and you read through them. And then, yeah, Friday, limits. Yeah, and make sure you go through limits yourselves. You go through limits. Yeah, and make sure go through limits and go through the signs as well, so that as we are going through next on Friday, we're not confused and not Otherwise, you guys should have a great evening, I guess. Yeah. Unless anyone has a question before I leave.
So that means we are done on sweets.
Oh no, we're not done on sweets.
Oh,
Yeah, we're not done on.
okay. But I heard next time you're going on limits.
Oh
The next
yes,
time is limit.
yeah. Limits are part of sweets.
Oh, okay.
Yeah. Otherwise, make sure you guys go through limits and you go through the work too, and read the notes and read the signs too. Remember the signs so you're not confused. Otherwise, bye.